Yeah, let me go for sharing some screen. Can you see the screen?
Yes, sir.
Okay.
Yes,
One
sir.
of you please respond. Are you able to see?
Yes, sir.
Okay, the fourth day of inverse trigonometric function. Again, as a reminder, we have discussed how the six inverse trigonometric functions are defined. Very importantly, the principal value branches, that is the domain and ranges of all six inverse trigonometric functions. Further, we go for the properties. Before going for the properties, let me just remind you what were the inverse trigonometric functions and elementary definitions. Sine of sine inverse x equal to x for all x in closed interval -1, 1. Cos of cos inverse x equal to x for all x in closed interval -1, 1. Whereas tan of tan inverse x equal to x for all x in R, cot of cot inverse x equal to for all x in R. What about sec of sec inverse x? It is x for all x in R -1, 1. That means x can be either less than or equal to -1 or more than or equal to 1. Same for cosec of cosec inverse x. Now the second point is sine inverse of sine y equal to y. Now remember, all six have different ranges for y, or I mean the domain for principal domains for six trigonometric functions. That will be the range of the inverse trigonometric functions. Sine inverse sine y equal to y, where y belongs to closed interval minus pi by 2, pi by 2. Whereas cos inverse cos y equal to y for y belongs to 0, pi. See the difference? One is closed minus pi by 2, pi by 2. For this is closed to 0, pi. Tan inverse tan y equal to y for y belongs to open minus pi by 2, pi by 2. And cot inverse cot y equal to y for open 0, pi. Sec inverse sec y equal to y for y belongs to closed interval 0, pi excluding singleton set pi by 2, and cosec inverse cosec y equal to y for y belongs to closed interval minus pi by 2, pi by 2 excluded 0. Remembering all this, now we go for the properties. Now these are the vital points. First one, formula for the inverse of negative numbers. This will help solving many of the questions where you struggled many points earlier. Sine inverse minus x is minus sine inverse x. Nothing to worry about. So this minus will directly come out. Sine inverse minus x is minus sine inverse x. Of course, x has to be in the domain of sine inverse, that is between -1 and 1. Whereas cos inverse minus x, remember, cos inverse minus x is pi minus cos inverse x. You may ask yourself how it is. I'll bring out a proof for that. Cos inverse minus x is pi minus cos inverse x, whereas tan inverse minus x is minus tan inverse x, but cot inverse minus x is pi minus. And sec inverse minus x again is pi minus sec inverse x, because x must be in the domain of sec inverse, whereas cosec inverse minus x is minus cosec inverse x. Before looking into the results once again, let me just bring out the proof for this. Sine inverse minus x is minus sine inverse x. Let me start by substituting sine inverse x equal to theta. When I say sine inverse x equal to theta, you know, theta will lie between, as we mentioned earlier, between minus pi by 2 and pi by 2, x included the boundaries. When sine inverse x equal to theta, we have x equal to sine theta, no doubt. When x equal to sine theta, minus x will be minus sine. Now we know sine function is an odd function. Minus sine theta is nothing but sine minus theta. Remember, we have minus x equal to minus x equal to sine minus theta. Minus x equal to sine minus theta. Further, when you go for sine inverse minus x equal to sine minus theta. So sine inverse minus x will be sine inverse sine minus theta. We have written the result. Sine inverse sine theta is theta. Sine inverse sine minus theta will be minus theta. Provided this quantity minus theta lies between minus pi by 2 and pi by 2. That's true. We have, because minus pi by 2 less than or equal to theta less than or equal to pi by 2. If I multiply with minus 1, I get here pi by 2. Inequality reverses. More than or equal to minus theta, more than or equal to minus pi by 2. Or we read it from here, that is minus pi by 2 less than or equal to minus theta less than or equal to pi by 2. Right? And therefore sine inverse sine minus theta is minus theta. But what is theta? Sine inverse x. So this is minus sine inverse x. So sine inverse minus x equal to minus sine inverse x. Okay? The first result is clear. Sine inverse minus x is minus sine inverse x. Let's take that for cos. Let cos inverse x equal to theta, so that x equal to cos theta. Of course, theta will be between from 0 to pi. Minus x equal to minus cos theta. But minus cos theta is not cos minus theta. Cos minus theta is cos theta. If we want minus cos theta, as I mentioned earlier, we have to look into cos pi minus theta. So minus x equal to cos pi minus theta, because we know cos pi minus theta is minus cos theta. Now when we take cos inverse minus x will be cos inverse of cos pi minus theta. Cos inverse cos pi minus theta will be pi minus theta, provided pi minus theta lies between 0 and pi. What we know is that theta is between 0 and pi. So minus theta, if you multiply with the minus 1, inequality reverses. Minus theta, 0 more than equal to minus theta, more than equal to minus pi. I am adding pi throughout. Adding pi throughout, we get pi more than or equal to pi minus theta more than or equal to 0. Or reading from this side, we get 0 less than or equal to pi minus theta less than pi. That is sufficient to take cos inverse. So cos inverse cos pi minus theta is pi minus theta, because pi minus theta lies between 0 and pi. Well, what is theta? Theta is cos inverse x. So this is pi minus cos inverse x. And hence cos inverse minus x is pi minus cos inverse x. Now look, how to remember? Few of them have direct minus, where sine inverse minus x, tan inverse minus x, then further cosec inverse minus x. We have direct minus, minus, minus. And the other ones, cos inverse minus x, pi minus cos inverse x. Cot inverse minus x, pi minus cot inverse x. Sec inverse minus x, pi minus sec inverse x. How will you remember this? Can you look back to the principal domain, or the first thing which we have written? Sine inverse sine y equal to y, cos inverse cos y is y, tan inverse tan y is y, and so on. And see the principal domain for sine, minus pi by 2 closed, and tan open, minus pi by 2, and for cosec, minus pi by 2 minus 0. See, there are three functions whose principal domains are associated with minus pi by 2, I marked with red, and three functions which are associated with 0 pi, where it is associated with 0 pi, cos, cot, sec, we have pi minus. Look at pi minus. Whereas associated with minus pi by 2, which are the sine inverse, tan inverse, cosec inverse, we have direct minus. So sine inverse minus x, minus sine inverse x, tan inverse minus x, minus tan inverse x, cosec inverse minus x, minus cosec inverse x. Whereas cos inverse, cot inverse, sec inverse, we have pi minus. Take care of this. Further, let us proceed with some examples here. Okay. Sine inverse minus half, it is directly minus sine inverse half, that is minus pi by 6. Whereas cos inverse minus half will be pi minus cos inverse half. Here now things are very simple. Cos inverse minus half is pi minus cos inverse half. That is pi minus pi by 3, that is 2 pi by 3. Cos inverse minus 1 is cos inverse minus 1 is pi minus cos inverse 1. That is pi minus cos inverse 1 is 0 because cos 0 is 1. Pi minus 0, that is pi. Cos inverse minus 1 by root 2. You remember that. Pi minus cos inverse 1 by root 2. Cos inverse 1 by root 2 is pi by 4. Hence pi minus pi by 4, that is 3 pi by 4. Okay. Tan inverse minus root 3 will be minus tan inverse root 3, that is minus pi by 3. Cot inverse minus root 3, can you spell? It will be pi minus cot inverse root 3. Pi minus cot inverse root 3 is pi minus pi by 6, that is 5 pi by 6. Sec inverse minus root 2, nothing to worry. We have the formula pi minus sec inverse 2, that is pi minus pi by 3, that is 2 pi by 3. Cosec inverse minus 2, that is minus cosec inverse 2, that is minus pi by 6. Now we go for formula for inverse, the second formula. First was formula for inverse of negative numbers. We have written all the 6 formula. Now we have the formula for inverse of reciprocal numbers. Sin inverse 1 by x. Cosec inverse x, it is for all x in the domain. This is 1 by x, sin inverse 1 by x. So mod x more than or equal to 1, then only mod 1 by x must be less than or equal to 1. Cos inverse 1 by x is sec inverse x. Tan inverse 1 by x equal to cot inverse x. Only thing to take here it is. This is valid only when x is positive. Even though tan inverse x and cot inverse x are defined for all values of x, this result is valid only when x is more than 0. Let us see how it happens. For the first one, I suppose sin inverse 1 by x equal to theta. Mod x more than or equal to 1. Well, when sin inverse 1 by x equal to theta, and when mod x more than or equal to 1, mod 1 by x will be less than or equal to 1. This is the problem. Sin inverse 1 by x equal to theta, so that sin theta is 1 by x. Now, actually, theta belongs to minus pi by 2 pi by 2. But 1 by x cannot be 0. So, sin theta cannot be 0, so theta cannot be 0. That means theta belongs to minus pi by 2 pi by 2, but not 0, because theta cannot be 0 as 1 by x cannot be 0 for any value of x. So, theta is in the principal domain of cosec inverse, principal domain of cosec function, so we can define cosec theta equal to x and theta equal to cosec inverse x, theta equal to cosec inverse x, that is, what is theta? Theta is sin inverse 1 by x. So, sin inverse 1 by x equal to cosec inverse x. Right? Now, let us see how this positive value is required for tan inverse. Tan inverse 1 by x equal to theta. Naturally, theta belongs to minus pi by 2 pi by 2. But as x more than 0, theta will be between 0 to pi by 2. Remember, if I simply take tan inverse 1 by x equal to theta, theta can be anywhere between minus pi by 2 pi by 2. But as I have restricted x to be between more than 0, tan inverse 1 by x will be naturally more than 0. That is, theta will be between 0 to pi by 2. If it is minus pi by 2 to 0, then tan theta will be negative and 1 by x also will be negative. Okay? So theta belongs to 0 pi by 2. So 1 by x equal to tan theta or x equal to cot theta. What about cot inverse x? Cot inverse x equal to theta, that is tan inverse 1 by x. Fine. Tan inverse 1 by x equal to cot inverse 1 by x. What happens if theta less than 0? If theta less than 0, theta will belong to minus pi by 2 0, where we cannot take cot inverse because minus pi by 2 0 is not in the principal domain of cot. That is the reason we cannot accommodate minus here. Of course, we can have a result If x is less than 0, you can easily prove that tan inverse 1 by x is cot inverse x minus pi. But as the result is not given for you, you can avoid that. In case if you encounter, we apply the first result and negative number, we make it a positive by applying the result 1. Let us take some example. Cosec inverse 2. Now you don't need to struggle about what is cosec inverse 2, because that is sin inverse 1 by 2. We know sin pi by 6 is 1 by 2. Sin inverse 1 by 2 is pi by 6. Sec inverse root 2, that is cos inverse 1 by root 2, that is pi by 4. Whereas sec inverse minus root 2, you can directly take pi minus sec inverse root 2, that is pi minus cos inverse 1 by root 2. Pi minus cos inverse 1 by root 2. Cos inverse 1 by root 2 is pi by 4. So that is pi minus pi by 4, that is 3 pi by 4. Cot inverse root 3 is tan inverse 1 by root 3, that is pi by 6. If you want cot inverse minus root 3, what I prefer is that we apply the result 1. We write first of all this as pi minus cot inverse root 3. This is from our result 1. This is our result 2. From our result 1, we have cot inverse minus 6 is pi minus cot inverse x. So this is how we circumvent will encounter cot inverse minus root 3. That is pi minus cot inverse root 3. That is pi minus tan inverse 1 by root 3. That is pi minus pi by 6. That is 5 pi by 6. Now the third one. See, first one was formula for inverse of negative numbers. Second one is formula for inverse of reciprocal numbers. Third is formula for inverse of complementary functions. What are complementary functions? Sine and cosine, sec and cosec, tan and cot. Tan and cot are complementary as well as reciprocal. Okay, sine inverse x plus cos inverse x is pi by 2. Of course, x must be the domain of sine inverse, that is minus 1, 1. Tan inverse x plus cot inverse x is pi by 2. Very simple result. This is true for all values of x. Sec inverse x plus cosec inverse x is pi by 2. This is valid when it is in the domain of sec inverse, that is mod x must be more than or equal to 1. What I prove? Proof is very simple. Let me put sine inverse x equal to theta, so that x equal to sine theta, and sine theta is nothing but cos pi by 2 minus theta. Cos pi by 2 minus theta is x. So cos inverse x is pi by 2 minus theta. What is pi by 2 minus theta? Theta is sine inverse x. So pi by 2 minus theta is pi by 2 minus sine inverse x. And taking sine inverse x to this side, we have sine inverse x plus cos inverse x is pi by 2. Sine inverse x plus cos inverse x is pi by 2. Okay? You recollect all the results. What was our second one? The third one is formula for inverse of complementary functions. Sine inverse x plus cos inverse x is pi by 2. Tan inverse x plus cot inverse x is pi by 2. Sec inverse x plus cosec inverse x pi by 2. Can you recollect what was second? Sine inverse 1 by x equal to cosec inverse x for all mod x more than or equal to 1. Cos inverse 1 by x is sec inverse x for mod x more than or equal to 1. Tan inverse 1 by x equal to cot inverse x for all x more than 0. Be careful about this result. This result I am stating only for positive values of x. In case if you are encountering negative values, you will circumvent by applying the previous result. What is that? Here it is. This was the first one. Sine inverse minus x is minus sine inverse x, where x lies between minus 1 and 1. Cos inverse minus x is pi minus cos inverse x. Tan inverse minus x is minus tan inverse x. Cot inverse minus x is pi minus cot inverse x. Sec inverse minus 6 is pi minus sec inverse x. Cosec inverse minus 6 is minus cosec inverse x. Where in sine inverse, tan inverse and cosec inverse, we have direct minus, whereas for cos inverse, cot inverse and sec inverse, we have pi minus. This somehow you have to keep in mind. You may have to apply many places, not only in mathematics, even in physics also sometimes when you encounter cos inverse minus 6, then immediately you must Respond to that. It is nothing but pi minus cos inverse x. I'm sure you need to apply this somewhere in physics also. Cos inverse minus x will be pi minus cos inverse x. When you want to find the angle between sometimes two forces, if you are encountering cos inverse minus x, it is necessary to respond to that pi minus cos inverse x. Well, let me pick a few questions here. Here now you have to apply these results also when you encounter these big angles, right? This you will definitely do. Let me pick up one more question which you have to answer to me right now. Can some of you answer me the answer to the question 10? What is tan inverse 5 plus tan inverse 1 by 5? Tell me the answer and tell me why. I will wait for your answer. Tan inverse 5 plus tan inverse 1 by 5. What is the value? Hello? Viraj? Well, today's results you could not chew. I will send the recordings. Tan inverse 1 by 5 will be cot inverse 5. Agreed? Tan inverse 1 by 5 will be cot inverse 5. So tan inverse 5 plus cot inverse 5 is pi by 2. What about the next one? Sec inverse 4 plus sin inverse 1 by 4. Sin inverse 1 by 4 is cosec inverse 4. Sec inverse 4 plus cosec inverse 4, that is pi by 2. What about cos inverse 1 by 3 plus cosec inverse 3? Again, we can put cosec inverse 3 is sin inverse 1 by 3. And when you have cos inverse 1 by 3 plus sin inverse 1 by 3 is again pi by 2. Or you can, no problem, you can put cos inverse 1 by 3 as sec inverse 3 also. Here also you can put sec inverse 4 as cos inverse 1 by 4 also. There also we have the result. Okay? Or here also tan inverse 5 or cos 1 by 5. Then also we have the result. You must do all the questions and you send the answers to me. And if you have difficulties, that also you send to me. Okay? All right? Now, you tell me. Okay? Now you tell me how it is getting along. Are you able to do the questions? Are you able to do all the questions which I give? You don't leave. There is no excuse. Don't leave any question which I give to you. Don't leave any question.